Hi, I'm Rick Rudder with News on the Feed. As the climate continues to warm and our dependency on technology grows, the need for more sustainable networking solutions is critical. Joining me is Chang-Hong, Engineering VP and Juniper Fellow, who just published the first Day One Green Paper. In it, he describes how our days of simply relying on Moore's Law to deliver faster, cheaper processing power are over, and we need to think differently, especially with demand for our networks continuing to grow. So, Chang-Hong, to understand where we're at today, can you please take us back to the 2010s and describe how we delivered gains in performance and efficiency back then?
The decade of 2010 really is a transition time for the semiconductor industry. As the decade progresses, we also notice as we increase the interconnect speed, the power consumed by interconnecting the chips, the ASICs themselves, are consuming more and more percentage of the power of the system. And so we got some innovation to use 3D memory. We are the first one in the networking industry to do so, and a serial with a serial interface. By that, we reduced the number of input and output required for the ASIC. We're able to integrate all of the packet forwarding function on the line card onto a single ASIC. And that improved the performance as well as the power consumption of the ASICs by 3 to 4 times in that duration.
Based on like those power improvements or efficiency improvements, did something change, right? Do you think you were able to continue to get those types of improvements using the same technology or same processes?
That's a very good question, Rick. During the second half of the decade of 2010, we integrated more and more function onto the same piece of die, same piece of ASIC. Yes, we were able to improve the performance of the networking products, but then the die size, the size of the chips we produce is getting bigger and bigger in the process. We introduced multiple slices, or if you will, think of it like a multi-core CPUs, putting more and more cores on the CPUs. But the end result is the die size gets bigger and bigger. By the end of the decade, many of the chips are actually approaching what we call the semiconductor reticle limit, which is about the biggest chip we can produce with the semiconductor equipment. And in the meantime, the number of defects on the chip is getting bigger and bigger. So the good dies you can get out of a wafer is getting smaller and smaller and smaller. And then that impacts the cost of the chips. So clearly, from both the die size increase as well as the cost of the chips, we cannot do this integration forever. We need to find something else to improve in the future.
Got it. And so from what I understand in reading your paper, like this is where we come at how we need to deliver more than more, right? In that sense of, the days of just seeing those automatic increases in performance and cost are no more. So we've got to think a little bit differently about how we innovate in the future, correct?
That's right. That's right. In fact, the whole semiconductor industry is encountering the same problem. I mean, you can see all the CPU manufacturers are doing that as well, from AMD to Intel and to the recently announced Apple's M1 Ultra. They are putting multiple of these dies inside the package. So you can see the shift of the design space, right? In the earlier the decade of 2010, we put multiple chips together to perform a function, and then we integrated everything on the same die to perform the function better. But now we're actually breaking it up again, but not in the old way of putting them on the board, which consume a lot of power. Instead, we are integrating them inside the package. With the low power interconnects that are developing in the industry, we're able to overcome the die size limit as well as consuming less amount of power in the process. That, in fact, is the way we see networking system and ASIC design is going to go in the near future.
That's awesome. So it sounds like we've gone from system on a chip to system in a package.
That's right. And some people call it a SIP, SIP, as in system in package. And that will take us the integration inside a die. Now is integration inside a package to take us to be better performance and lower power in the future.
And I would imagine better performance and lower power consumption also equals a more sustainable product as well.
That's correct. And we are working very hard to deliver those products in the market, and we'll say more in the coming month on how we are going to accomplish that. And in terms of the sustainability, currently, the first thing when we're designing a next generation product, we look at power consumption, right? Before, the power consumption, in a way, is a byproduct of the design improvement, but right now is actually the first order of business is to reduce the power because our power delivery as well as cooling ability are all approaching the limit of the state-of-the-art technology can do. So this is very important. And in the meantime, when we are focusing on power, we are delivering a more sustainable product for the planet as well.
Well, listen, Chang-Hong, I wanted to thank you so much for joining us today and for also working so hard to create a more sustainable network. To read Chang-Hong's paper, please check out the link below. And to learn more about how Juniper is addressing climate change, visit juniper.net/climate. And while you're on the feed, please take some time to soak up a little industry news and knowledge. Thanks again.
Yeah, thank you, Rick.